Hello everyone, welcome to MacroEdtech. We are excited to bring you a comprehensive 30-day revision series for UPSC Civil Service Examination Prelims 2026. Especially we are going to focus on paper 2, which is CSET. This series is carefully designed to help you revise concepts, improve problem solving skills, and build strong exam confidence in a structured and time-bound manner. Starting from today, which is April 21, and will conclude on May 21. So overall, this is a 30-day series, and you can watch the recorded session daily at 8 p.m. Make sure you stay consistent, follow the schedule, and practice along the session to get the maximum benefit. And in case you have any doubts or queries, feel free to reach out to at info@macroedtech.com. Let's stay focused and make this journey count. In today's short video, we will see total 3 questions. So question number 1, a natural number n is such that it can be expressed as n equal to p plus q plus r, where p, q and r are distinct factors of n. What do you understand by this? Means if we put here p equal to 1, q equal to 2 and r equal to 3. So 1 plus 2 plus 3 equal to 6, and 1, 2, 3 all are factors of this 6. So how many numbers below 50 have this property? We have to give answer, and our options are 6, 7, 8 and 9. Now we'll try to solve this question. Let's start. As per the question, n equal to p plus q plus r, and currently we don't have any standard form, so we'll use hit and trial method and make some valid guesses as per conditions. So first case, suppose p is 1, q is 2 and r is 3 and sum is 6, and all three conditions are satisfied because n is 6, summation 1 2 3 is 6, all are the distinct digit and all are the factors of 6. Now second case, 7 is not possible. 7 is not possible if we take 2 plus 3 5 plus 2 possible. It is not possible because 2 repeating 2 times, so we need distinct number. We can take other like 4 plus 2 plus 1, but 7 is not, all the numbers are not factor of 7, so it is also not possible. Similarly 8 is also not possible because if we made 4 plus 2 plus 2 is not possible because of the repetition, and if we make another number 4 plus 3 plus 1, here 3 is not factor of 8. So in similar way we can assume that the 7 is not here, not fulfilling the condition, not 8, 9 is also not there. In similar way 10 is also not there, 11 is also not there, but we will use 12. Why? Because 12 have, we can summation use 2 plus 4 plus 6. Why we choose that? Because we need numbers, first the distinct number and make factors of 12. So these all are the factor, 2 is also factor, 4 and 6. So now we can easily understand the pattern. Now third one would be 18, because it's like 6, 12, 18, 24, 30, 36, 42 and 48, because we need number below 50. So how can we make 18? 3 plus 6 plus 9. Now next, would be 24. And how can we make 24? Like first we can 12 and then 12 plus 8, 20, and make again 4. So all are factors of 24. Now next one is 30. How will you make 30? Take 15, 10, and 5. Here all are factor of 30. In similar way, we take 36, and how can we broke it? Like we can take previous number like 18 plus 12 plus 6. Here you can say the summation of all previous n is equal to 36. So obviously all are the factors of 36. Now next one is 42. And how can we break 42? 7, 14, 21, and 21, 21, 42. So this is also factor. So we need give answer total number of counts. Eighth case 48. So we can easily make like 24 plus 16, 40 plus 8, 48. So this is also valid case. So we have total 8 cases there. So answer is 8. Now please pay attention here to understand general pattern. Suppose instead of P plus Q plus R, question will be P plus Q or P plus Q plus R plus S. So how will we solve? So we can, instead of checking each number randomly, we can assume that factor are in the ratio. Here you can see here, suppose Px, so Q 2x, R is 3x, S equal to 4x. So at the end of first question, I would like to summarize some cases. Suppose we have two factors, P plus Q. So in this case, you can use this standard form. Means n is a multiple of 3, like 3, 6, 9, 12, 15, 18, and so on. For 3 factors, we already solved. These are the all n's are factors of 6, like 6, 12, 18, 24, 30, and all. Similarly, for 4 factors, n is a multiple of 10, because we already put, means n equal to p plus q plus r plus s. So all are the ratio 1, 2, 3, 4. So total sum is 10. So all number would be multiple of 10. Now question number 2. Consider the first 100 natural numbers. How many of them are not divisible by any one of 2, 3, 5, 7, and 9? To solve this kind of question, because there is a not present in question, so first we will find the total divisible number and then we will subtract from 100, right, to get answer. So let's start to solve this question. So as per the question, we have 2, 3, 5, 7, and 9. But you can see here 9 is redundant. Why? Because it is already 3 is covered. So you can read here the explanation. If a number is divisible by 9, it is already divisible by 3. So it is a redundant number. 9 is a redundant, so we can remove it. So now we have total 2, 3, 5, 7. So we have to find the count numbers which is not divisible by 2, 3, 5, 7. Concept behind this question is inclusion exclusion principle. Without Venn diagram, we can solve this question. The inclusion exclusion principle is counting technique used to find the number of elements in union of overlapping sets. So in this case, first adding the sizes of individual sets, Then subtracting the sizes of pairwise overlaps. Third, adding back triple overlaps. And fourth, counting alternately, means like you can see here, we add A, B, because first adding the size of individual, then subtracting the size of pairwise. So this is single, individual, now pairwise we subtract it. Means these are the pair, means common. So we will subtract it. In similar case, when there are case of 3 means A plus B plus C. So in individual we will first add then subtract, because second case is subtracting the size of pairwise overlap. So we'll subtract AB, AC and BC, and then third one is adding back triple overlaps. Then add all A plus B plus C. So in similar way we will solve this kind of question. Now let's understand and solve this question. To understand more clearly, I just want to explain one example here. You can see here, from 1 to 100, a natural number 1 to 100, how many numbers are divisible by 2 and 3? So we will try to divide by first 2, there are 50, and if we divide by 3, we will get 33 without any kind of remainder. So there are total 50 plus 33. And what is the common? Common, how will get the common? LCM of 2 and 3 is 6. So 100 divided by 6, we will get 16. So you can see here, individual 50 plus 33, and we will subtract the common 16. So we will get answer is 67. So this is the answer of this our example. Only I took one example here. Now back to our question where we have 2, 3, 5 and 7. So individual counts means first we will divide 100 by 2, we will get 50. Similarly, 100 by 3, we will get 33. Now divisible by 5, we will get 20. Divided by 7, we will get 14. Now the sum of all the numbers 50 plus 33 plus 20 plus 14, we will get 117. Now we will make pairwise intersection. So now we will make pair 2, 3 and LCM is 6. Now pair 2, 5, LCM is 10, 2, 7, LCM 14. In similar way, we will make 3, 5, 3, 7 and at the end last 5, 7. LCM is 35. So when we divide 100 by these all numbers, we will get this. Means we have to divide 100 by 16, 100 by 6, then 100 by 10, 100 by 14. So in similar way, we will get this result, and when we add all numbers, we will get 45. Next one is triple intersection, where first one 2, 3, 5, LCM is 30. When we divide 100 by 30, we will get 3. Next one 2, 3, 7, LCM 42. Divide by 40, we'll get 2. Next 2, 3, 5, LCM 70, and when 100 is divided by 70, we will get only 1. And next one is out of range because it's more than 100, so we will not take. So total we have 3 plus 2 plus 1, there is an equal 6. Now as per our standard formula of inclusion exclusion, first one our 117 first case, second in pair case there are 45, so we will subtract, and now again in third triple intersection we will add in 6. So 117 minus 45 plus 6 equal to 78. Now, what is our final answer? Because they asked not divisible. So, their 78 means all the divisible number divided by 2, 3, 5 and 7. And also 9 because it is a part of 3. So, we have to find not divisible. So, 100 minus 78 and we will get 22 is our final answer. Now, question number 3. What is the maximum value of n such that given number is divisible by 35 to power n? So overall we have to find the maximum value of n for which 35 to power these number maybe 3, 4, 5, 7 is completely divisible. Here's the one concept and catch behind this type of question. So what is the core idea? Core idea behind maximum value of n. Whenever you see maximum n such that a number is divisible by a to power n, this is the general form. So you must think immediately that there is a need of prime factorization plus minimum power rule. Now let's understand these two terms, prime factorization and minimum power rule, with the help of solving this question. Now understand the core idea, prime factorization and minimum power rule. So we have 35 and we can write in prime number 5 into 7. Now you can see here 35 to power n. So we can rewrite 5 to power n into 7 to power n. Now second point is minimum power rule. To get maximum value of n, we need n equal to minimum of power of 7 and power of 5. Because the prime factor of 35 is 5 and 7 and both are prime numbers. So we need minimum power of 5 and minimum power of 7. Now step 2, break each number into primes, because we have given number 7 into 343 into 385 into 1000 into 2401 and 77777. So now break each number into primes. First 7 is already 7 to power 1, 347, 343, 7 cross 7 cross 7 means 7 to power 3. In similar way, you can see 385. So we can, because we have 5 and 7 prime factor and we'll multiply by 11. So these are some by the general assumptions we can easily find them because we need only prime numbers. So 5, 7 and then 11 we can easily multiply. In similar way 10 we can use 5 into 2 because we need prime numbers. Now 2401, because we already had 343, we can easily multiply by 7, so we get 2401. This is a standard form. Actually, generally in many questions they asked. So you must remember 2401 is 7 to power 4. Now next, we can easily separate 7 and then multiply by 1111. So here also 7 to power 1. So ultimately we need minimum power of these two. Now we will check. Now the total powers, first power of 5, in 385 in our previous number we got only 1 and in 1000 we got 3 because there were 2 into 5 to power 3 means 5 to power 3. Now power of 7, there is 1, 3, 4, 3, there is 7 cube, so there is 3. 3 at 5 only 1 7 2401 7 to the power 4, and in this case also there is only 1 7, then rest one is 111, so there is a power 1. Now we will add them. Count 3 plus 4, 3 plus 1 4, and 1 3 4 5 9 and 1 10. So minimum, we need minimum. So which is minimum here? 4 is minimum. So 4 is our correct answer. Now please read some basic and standard formulas, because sometimes these formulas may be helpful to solve some questions. So please remember, sum of first n natural numbers, as we know that n plus 1 by 2. Sum of square of first n natural number, n plus 1, 2n plus 1 by 6. Sum of cube of first n natural numbers, which is generally square of sum of first n natural number, you can see here. But my ultimate aim to give you these two formulae, because maybe asked in question in some tricky way. So sum of first n even numbers, so means like a 2 plus 4 plus 6 up to 2n. So please remember, this is an n plus 1, and you can simple just write these number and you will easily evaluate this. And next one is sum of first n odd numbers, 1 plus 3 plus 5, because please remember this is the first n and first n, even and odd. So that will always start from 2 and it will also always start from 1. So it is a formula is n square. So in this session, I solved total 3 questions and informed you regarding the concepts associated with that. You can connect with me on LinkedIn. Your QR code you can scan here. Also, the link is provided in description. So thank you for your time and attention. I hope you enjoyed the session and learned some useful concept today. In the upcoming days, we will continue solving more questions to strengthen your understanding and boost your confidence for the CSET examination. You are also welcome to suggest topics that would you like to learn or practice. Your input will help make our session more effective and focused on your needs. So thank you very much again, and see you next session tomorrow.